beautiful people, and welcome. In today's video, we're going to be practicing for our quiz on functions. Now, this is the first quiz that you're going to have. It's going to show you what you know and what you still need to work on for your unit test. As always, if I make a mistake, please let me know where the mistake occurs, so that way we both can learn from my mistake, and you don't have to make yours on the quiz. All right, let's go ahead and get started with number 1. What is the value of f of x is equal to 1/4 x plus 2 for f of 24. So whenever you see things like this, f of 24, what I recommend is taking that and writing it directly underneath f of 24. And immediately when you do that, you're going to notice something pretty cool, and that is your f's, they match up. However, your x now becomes 24. So that means anytime you see an x in your equation, you're going to put it in a bubble and write 24. So now what do I have? I have f of 24 is equal to 1/4. We need to put the x in a bubble. Here's my bubble. And instead of writing x, I'm now writing 24. Remainder of the equation, which is plus 2. So now that we have that, we're going to evaluate. Now this right here on the left hand side, this stays the same. This is just saying like y. Okay, this is our y. This is the function evaluated at 24. You don't actually have to do anything on that side. Now on this side, we do have to do something. So I have what 1/4 of 24. So one way that you can do that is you can rewrite this in terms of fractions. So I can say I have 1/4 times 24 over 1. You can make 24 into a fraction. Multiply these, so I have 24 divided by 4 plus 2. 24 divided by 4, that is 6. I have 6 plus 2. So f of 24, the function evaluated at 24, is 8. And that is your answer. Let's move on to number 2. Number 2 is a little bit different. Now it's telling us, here's the same equation, f of x is equal to 1/4 times x plus 2. But now we're saying f of x is equal to 6. So if I do the same thing, if I take this and write it underneath, f of x is equal to 6. Notice that my f is the same and my x is the same. That means I still have x. However, these two things, notice I'm going to put them in a bubble, they are equal to each other. So I'm going to rewrite this as 6 equal to 1/4 x plus 2. Now the difference between number 1 and number 2 is that for number 2, we are going to solve for x. Our objective is different. Our objective is to get x by itself. So how do we get x by itself? I'm going to subtract 2 on both sides. So now I have 6 minus 2, that is 4. I have 1/4 times x. Now here's a trick with fractions. Whenever you need to divide fractions, for example, right now, actually, let's do this. Let's multiply this. So this says I have 4 is equal to 1/4 times x. Let's make x into a fraction. So that means I have 4 is equal to x divided by 4. So what is the opposite of that, of divided by 4? We're going to multiply by 4. So that means x is 16. And that is my answer. Notice how different my answers look for number 1 and for number 2. Big difference. All right, let's move on to number 3. Is the relation a function? Explain why, excuse me. All right, so what does it mean to be a function? A function is for every input, there is a unique output. Now you should know this already. Input is our x values. Those are our domains. And output are our y values. So for every x, there should be only one y. So when you're doing something like that, I'll give you a hint. You're looking for no repeats in the x. So are there any repeats in the x? There are not. So for one input, there's one output. One input, one output. One input, one output. One input, one output. One input, one output. It doesn't matter if there are repeats in the y's. As long as there are no repeats in the x's, you are fine. So it says explain why. So our answer for this one, is this a function? Is this relation a function? Here's our answer. Yes, it is a function because for every input, there is a unique output. Now, here's something that some of you will trip up. Just please be careful. Order matters. Input, then output. Think of the alphabet. What comes first in the alphabet? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. So make sure that you're just like in the alphabet, the input comes first and then the output. So one input, one output. What is the domain and range of this relation? Okay, so we kind of already went through this. Let's do this. So an input is an x, and an x is also known as the domain. Domain are all of the possible x values. The range are all of the possible y values. So we're looking here. What is the domain and range? Let me write out the steps because there are steps to writing domain and range. Step number 1, you need squiggly brackets. Step number 2, you need to do order like a number line. That means there are no repeats. And that means you're going from the smallest number to the largest number. And you need commas to separate the numbers. Separate the numbers. Okay, so what that means here is, here's my domain. I'm going to do a number line. Here's my range. I'm going to do number line. Again, domain are our x values. Range are our y values. So I'm taking all of my x numbers. I'm going to just take all that I have for my x's and I'm just going to do it on the number line. So this is my little 0. Now I'm doing a little 0 because I don't know if I actually have 0 as a number. So I don't want to make it too big and write that into my domain if I don't actually have it. So here is -3. It's pretty big because I have it. Oh, I do have a 0, so I'm going to make that bigger. Then I have 1, I have 2, and I have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just like you do on a number line, that's what you're going to do. And I'm going to do the same thing for my range. For my range, here's a little 0 because I don't know if I have it. I have 4, 1, 2, 3, 4, 5, 6, 7. I have a -1. I have another 4, and I have a -1. But they are already on my number line, so I don't have to write them again. So let's do the answer for my domain. Squiggly brackets. And I'm going to take the numbers that I see, just like in that order, -3, 0, 1, 2, and 10. There are no repeats in my domain. They're from smallest to largest, and they are being separated by a comma. This is your domain. Now let's do the same thing for range, squiggly brackets. Looking at what I have. Now make sure that you don't include baby 0 unless you can make that 0 bigger by having it in your domain or range. In this case, range, y value does not have a 0, so 0 is not included in my range. So I have a -1, comma, 4, comma, 7. That's it. There are no repeated numbers. There are from smallest to biggest, squiggly brackets and separated by a comma. That is your range. All right, do some word problems. Now these word problems we're just going to translate. Julie has $90 in her wallet. $90, we know that's a number in her wallet. It's not really important. We just need to know that that's our starting number. Each day, so every day, she places $3 more into her wallet. Write a function that shows the amount in Julie's wallet after D days. Okay, so we're translating. What's our starting number? What is in her wallet right now at this moment? At this moment, she has $90 into her wallet. Now, what is happening? What is happening is we're going to add $3 more into her wallet every day. So if she is adding money into her wallet for the first day, she's going to have 93. What happens if she's adding her wallet the second day? Well, she has $90 on the first day. On the second day, she already put the 3 in on the first day, so that's the first day. On the second day, she's going to add $3 more. On the third day, she's going to add $3 more. On the fourth day, she's going to add $3 more. So notice that every single time she's adding 3 more. This is the original, right? This is day 1. Day 2 is taking day 1 stuff and doing it more and more and more. So how do we write that as a function? Because we want write a function. Read the directions. It has to be a function notation. So to write a function, we want it in D days. So instead of putting F, we're writing D. We have $90 in her wallet, and we're adding 3 days each day. So how do we represent that how do we represent that in multiplication? So we're going to write times D. Each day, she gets $3. So if there are 5 days, we're going to add $15 to our original 9 days. So in 4 days, we're adding 3 times 1, 2, 3, 4. In 3 days, we're adding 3 times 3. In 2 days, we're adding 3 times 2. In 1 day, we're doing 3 times 1. So if we don't know how many days, we're just going to leave that bubble as a variable as the letter D because that's what they told us that we need it to be. After how many days will Julie have $120 in her wallet? Now, you can continue this, but that's not what we're trying to do because that's going to take you a little while. Take your function f of x is equal to 90 plus 30 days. 90 plus 3d. Excuse me, I don't know why I got 30 days. So 90 plus 3d. We want to know when will she have a total of $120. When will that happen? So we're going to set this equal to 120, and we're going to solve for my variable. Now here's a term, here's a term. We need to get rid of that term. How do we get rid of that term? We're going to subtract by 90. Here's my dotted line. I'm going to subtract by 90, subtract by 90. What do we have? That goes away. I have 3d is equal to 90, 100, 110, 120. So that means I have 30 here. And then again, we're solving for d. How is d attached? They're attached by multiplication. How do I undo multiplication? By division. So I'm going to take 30 divided by 3. I have d left over, which are days. And so 30 divided by 3, that is 10. Now, if you give me this as my answer, I'm going to mark it incorrect because I don't know what this is. This is 10 equals a letter. What does that letter represent? You have to be more specific. So you have to rewrite your statement. So after how many days will Julie have 120 in her wallet? After 100. Let's try this again. After 10 days. And that would be your answer. Please make sure that you are restating what is given, or else it will just seem like a random number. All right, beautiful people, this is exactly how your quiz is going to be for functions, for the beginning of functions. Thank you so much for watching this video. If you have any questions, please reach out. And as always, thank you again, and I will see you in my next video. Bye.